I had hoped to get up here to show you the setup on this paper patterns onto the sheet of plywood. We had these patterns printed at MicroCAD in back of Orr. It's right across from the SM Mall, sort of diagonally at the front entrance. Upstairs, it's a two-story strip mall. Anyway, they print all our stuff like this. We've been happy with them, and not so much with the price. Anyway, hey, that's Nane. He's he's a master skim coater. I think he did all these ceilings, and I'll guarantee they didn't look like that when he started. There's no render on those ceilings. There's just a little bit of touch-up concrete at seams and stuff, and then he did the rest of it with skim coat. And I imagine he'll have 2 days on this room when he's done with it. We're not using any rendering at all on this room. This is our fan housing. I'm probably picking up a bunch of wind noise on the camera because we have wind here 24 hours a day. Not as strong at night, but we have wind all the time. Okay, so let's see if we can explain this a little bit. The printer over there, we commonly use the 42-inch wide large format printer up there because I know they have a couple of them that size, and that's the one they used for our building permit. They took the CAD drawings, which are electronic on a thumb drive, and they printed an acetate sheet. And from the acetate sheet, which is where they generally end up starting with, they printed 8 copies of everything for the building permit. So I knew they have that 42-inch, and I just draw everything up with 42 minus a 3/4 border. I just draw a square that big, and then a rectangle. And as long as you want, I can. I've done them 150 inches long, better than 12 feet. Because that's how long the parts were, you know, and if you can nest all your parts to use up all the area of the paper, there's no reason not to make it longer because it's easier on them, it's easier on us, less wasted material when you go to cut it out. Anyway, the way this was done is they took a sheet of phenolic board, just like this one up here at the top of the work table, just a new sheet. They rolled the pattern out on it. Now one end, because we couldn't print 48 inches, we made a supplemental piece, and that was off the end here. So this piece you're looking at is one of the tails that was left when we took the supplemental piece here and cut it off the pattern and used duct tape and stuck it on the 3 pieces that were actually on the print. And then we centered that up on the plywood, which gave us about 3/4 or more around the outside edge. You can see it laying on the floor. That's how much was left. There's a few more down here. There's a foot. So the pieces aren't that much waste. Anyway, you tape down one end. It could be either end, except that this one had all uneven tails on it. So we tape down the tails. And then you go to the other end and you get a piece of PVC pipe. In my composite shop back in the States, I used 2-inch pipe for patterns, but what we had here was 3/4. So we used 3/4. You roll your pattern up past the center line of the sheet. We went about 60 inches or so out of 96, and throw a weight on it. And you want to roll that up fairly tight onto the pipe. Don't get all bunch in heaps, you know, flopping around on one end. Anyway, you put your wallpaper paste on the side that you've unrolled it off of, and then you roll the pipe back, and it puts the sheet back exactly where it was when you rolled it up, because the other end was taped and never taken loose. And when you unroll it, the pipe just unroll straight back to where you started rolling it. As long as you keep the tension on it when you unroll it, it goes. I work at tolerances of 1/8 of an inch back in the States, but it's tedious to try to get that much out of a sheet. But if you're cutting up 35 sheets for an aircraft fuselage, for a compound curved fuselage, one sheet starts to look like money. Because I use 11-layer birch plywood there. I think this plywood has a lot of layers in it. Yeah. You can see that this is about the same kind of plywood. The only difference is if you cut this, you'll let it run through concrete. Any voids in plywood here, they tend to fill with concrete. Now this is crocodile phenolic board, and we've not run across concrete inside of it. But we use another brand. I don't want to name anybody's brand, but we've wrecked a few carbide saw blades running through a streak of concrete. There was damage in the core, and they just filled it with cement and kept on going. Anyway, once you get your one side glued down, you untape all this, of course, and what they call it booking wallpaper. You take it and you just fold it back over on the part that's glued down, and it'll stay right there. You really don't. You can put a weight on it, but you don't generally have to. You put your wallpaper paste down, and now you got this shorter end that you can reach. So you grab the corners of the paper and you sort of keep it tight as you pull it back, and then just lower it into the wallpaper paste. So you got it stuck on there. First thing you'll notice is it's all puckered up with like air bubbles. The paper takes on water and expands. So some places it's stuck, and some places it pops up in these big bubbles. Looks terrible. So what you end up doing is you roll your pipe back and forth over it. You can't drag anything like a piece of board or a squeegee or anything like that. It drags, because it'll tear the paper and move it right along with you. The paper is really soggy from the wallpaper paste. But you can roll a pipe and somewhat mash it down. It'll still look like crap, but hey, you're into it then. You've already used up your paper and your plywood and your paste. You may as well see what happens. Next day you come in, and you'll notice that the bubbles are pretty much disappeared. There's one down here. You can see that one, I think. See? But most of it, as it dried, they pulled back out. The actual parts. There's a bubble right there. There's a couple here. And what you're looking for is where the ink lines go across a bundle. Are they offset, like looking beside each other? Then you need to take that into account when you're sawing this stuff out. But you just saw it out. And the way this thing works, it's the one we're looking at here. There's 27 blocks of wood here. This is a piece of stock. This is not cut to 5.5 yet. But you put these 27 pieces in. This black thing is just a place to drill a hole at each end so you can put screws in from the other side. These are in mirror images, so you have a pattern facing in on both ends. That's the things assembled and assembled with the top taken off so they can see what it looks like inside. And the goal of this is to drag a template. This was an earlier attempt that I couldn't get anybody to understand, and I'm not saying this wouldn't have worked, but it left me a little squeamish. Anyway, this piece is going to have a piece of wood up here at the top, and it'll drag along the top curved edge of this form, and it'll make that shape. It takes about 3 passes to do it. It won't be the first time you throw the concrete in. And the bottom of it, we have some thin plywood, but you can put cardboard or whatever you want in the bottom. And the purpose of the thing in the end is, this is a mirror image of what our edge of our counters to look like. We want a round end up at the top when you lean on the counter. And we want some places here that are drip edges. If something's running down off of it, it won't run down up under the counter and into the cabinets underneath. So there's some pointy things that make it drip off. But that's just us. if you have a straight counter, you don't need to do that. We're going to make some straight sections, same kind of box. Actually, we could probably make them by turning this box upside down, the longer one. Just lay a piece of lumber in there and have at it. I'm going to mention that to them. But what we've been doing is cutting a piece of 3-inch PVC pipe lengthwise, 180 degrees, 2 equal halves. And we put that into the edge of the form, and you fill your concrete up to the ID of the pipe. And we haven't ever got around to taking the forms off when it was like 2.5 hours old, where we could blend that edge. So we just blend it with a diamond wheel on a sander. Diamond sandpaper like you use on edges of tile and stuff like that. Anywho, I'm hoping there's not a lot of wind noise on this, because this house is designed to amplify wind. Right now, the only way it's building, boosting it is these 10 or 11 windows like that. The outside out there is 6 times the area of the window, and it's tapered in like a funnel. So it just forces all the air to come through this hole. And then there's every window in the house, there's one on the opposite side of the house over there that matches up with this one. And so when the air goes through, it sucks heat from down below during the day. This floor is not a floor. These are not rooms, and this is not a floor. There's a catwalk, 42 inches. It ought to be in sight. I can't believe it's wider than that. But this gets a handrail around it. And then we get a 7-meter fan. It's anchored up here at the top. Don't see the fan ring. It fits on the bolt holes on that jig over there. Oh, here's the thing on the floor. It was a dog that had bit me. There's the 2 closest space holes are on the bottom flange, and the other ones are angled. And those 2 holes, that there'd be 20 of them. It's 10 segments. The guy doing the skim coat covered over a few of them, but I know where they are. I can get them right back. Yeah, see in between those can lights? That's there'll be threaded rods up. Concrete's 31 inches thick right here, and the rods go right out the top. And then above that is where the wind turbine goes, on the other end of the same bolt. Some of our must-have tools. Power miter saw. This is an Ozito from Australia. We've used it since the beginning. Another indispensable thing, the DeWalt screw gun. 268 is the one we like the best. This is a 272. The motor and the drive is the same. The difference is how you take the bits out. This is sort of like a magnetic thing. You just push the bits in. And it says in the manual you pull them out with pliers. These guys can grab them with their fingers and get them out of there, but you really do need pliers. And they have adjustments on how hard to drive screws, because these are for metal buildings. Self-tapping tech screws, and you screw them through the sheet metal and then into a purlin or something like that, or C-channel, whatever you're attaching it to. Anyway, we have a couple of those, and we use these screws over and over and over again. I was going to show you what the screw heads look like. They're like a spline drive. They don't slip at all. In some really hard, like NAR or something like that, you might wring a head off every once in a while, but generally they come right back out. And if we're putting them in something hard like that, we put wheel bearing grease on the threads before we screw them in. This is a DeWalt, 110 written on it if it has to be on the transformer. Oh, DeWalt 331. It's been here since the beginning and does very good. We also use angle grinders by Maxell in Milwaukee. Our circular saw is a Black & Decker. We bought a replacement. We bought exactly the same thing. We were happy with the saw, but the guard for the spring wouldn't stay on for the safety on the guard. And I don't know what we did to it. We somehow damaged that thing. We're keeping it for parts. Down here somewhere. That's a roller. 3-roller roller. You adjust it with this thing on the top. We count how many turns it is from when it makes contact. This is a chart of all the different diameter radiuses. And this is how many turns. It's actually flats. It's not 39 threads, it's 39 flats. We count flats because you take the wrench around once and it's 6, and second time 12, 18, 24. When you get down the end, you count actual flats. Once you put a bend in it, you can't unbend it. You can unbend it, but you can't re-roll it. That doesn't work. Reason we have to have a roller is these rims for windows. They need to be a pretty accurate rim. It wouldn't look good if they was all lumpy. Doors, they have a rounded top. There was a stack here a day or two ago. Now we got a lobster over top of a conch shell. I think that goes in a door. Well, we're going to turn this into a walk-around video. I can call it that. People like walk-around videos. I might get 5 views on this video. This is a work in progress. It's pretty well along. This wire is used for 3-way and 4-way switches. It comes from another panel over here. This one is about done. It's got the wires in it. The wires are mostly pulled into the boxes everywhere. It's just that that one there feeds a room here with nothing but some lights in the ceiling. There's 1, 2, 3. A double spotlight. That way we can shine it down here on these helical stairs. That's Boyette. He did the skim coat work and the rendering that was done on these stairs. Oriel, I think he was working with Boy and Benji, and they built the formwork for these stairs. We like to say it only took 2 weeks, which is what it took, but it was an awful 2 weeks. We're doing the. There's another set goes outside that door, goes up onto the wind turbine deck, and that's going to be a central spine with the steps bolted to it. These are, since we're now doing a walk-around video, we've changed the title. Those are the ones that Oriel built last week. He built 8 8-foot forms, 4 4-foot forms. And we already had a couple of shorter ones. This way we can do the entire cistern like a rectangular shape, you know, with the around it in one pour. The cistern is the biggest pour we have. It's a fairly large hole. 37,800 gallons U.S. If I hadn't interrupted him, he would have finished this. These holes that look like they're only half in it, they're supposed to be that way. That's so that you can use a set screw on the other side and push a bearing race out. There's 2 races goes in that There's a spherical 222 016L and 250, 272, 580 and a 272 cup and seal, cup and race Timken. The Timken balances the Timken that goes in, I don't know where his housing is. That piece there goes between them. It's part number 6, but I don't know where it is. This down here is the flange for the where the blades for the fan go on. It goes on a 3-inch shaft. And that's welding hubs over there with one of the hubs, and they fit into this recess to center it up. And the bolts go through one hub through this center and bolt to the hub on the other side. I have to open up the holes on the center from, that's a 5/16 hole. We started out, we drilled the 5/16 pilot holes on every hole, and then we come back and line board everything. So some of them are to finished size, but those particular ones are not. And there he is. This gets a 6461 and a 6462 Timken bearing. It's a bigger bearing. Goes on top, and the weight hangs on that. But you can't run a Timken bearing by itself. It climbs out of the race. So that's why we have that one that's sitting on the drill press. The Timken bearing is to load this Timken bearing, and the spherical bearing is for radial loads from the fan. Just those. Doesn't shake the whole building. Well, somebody's going to build a house right next door. They're putting up fence posts anyway. Good luck, fella. Somebody will claim the land is sitting on, they'll tear them right down. I'm done putting fences up. I put them up 3 times already. No more. So we came to talk about putting paper on plywood, how you roll it up on a pipe, put the glue down, and roll it back right where it came from, because your other end is taped where it can't slide around. You know, that's your anchor for what you're doing. It wrinkles up when you put the glue, but the wrinkles mostly go away. And we explained what that's for. That's to make the edge on that countertop downstairs. So that's all for this video. Let's turn this off.